Thanks very much, Ben. I really appreciate it. I can't tell you how great it is to, first of all, to see you and to be in touch, and second to spend some time with your chapter. It's really nice to be able to bridge the gap in this time when it's challenging to get together physically, when there's a lot of unknown, when we're trying to figure out what's the right way to manage risk, what are people comfortable with, just like you're saying. And in ISACA, South Florida, where I'm currently serving as the president of that chapter, we're going through the same exercises that you are, that your entire chapter is, that you are personally, but collectively also. And doing these types of online events, I'm thrilled that your chapter is taking leadership and doing an online event and making it open to the public and having all kinds of people here to talk about this very important topic, at least a topic I'm very passionate about: data analytics for IT assurance and how to use data-driven strategy and tactics. So it's hard to start off this conversation and really even set the context for the importance of what we're going to discuss without acknowledging the disruption that Ben's talking about, that I'm talking about, that we're all in, the disruption of working in remote environments, the disruption of using new platforms, the disruption of what this is like with a lot of people's personal and professional lives. And so actually, I'd love to, if it's all right with you, I'll just go ahead and start off this conversation with a real brief poll to understand kind of where people are in this. And so I'm putting up on the screen right now, and I hope that you can see a poll talking about the impact of the pandemic for you personally, you sitting in your office or at home watching this. And I'm asking you currently, are you physically going to a shared workspace or office or whatever that means for your environment, or are you working remote? And then, because there are many different types of work arrangements, I'm also allowing that there are many people, especially in our profession, right, who were working remote even before the pandemic. So I want to capture that as well. And then, of course, it may always be the case that someone's not going to a physical space right now, but it's something that's entirely unrelated to the pandemic, right? So we don't want to improperly skew the poll in that direction as a result of that. And what this will do is it'll allow us to, better set the context for this and understand where each other are right now, and also help show your chapter leaders where some of you are right now. And at the same time, give a great example of a summary statistic, which we'll be talking about in just a little bit, that helps to shine light and information on this. So I'm going to go ahead and in that poll now. It was up for about 60 seconds, and now I'm going to share the results with you. So you'll see that there were a number of respondents, somewhere close to, I think, 80 respondents is what we had, and 79% of people are not working in a physical office workspace right now. They're working remote, and it's directly due to COVID-19. So you still have a large percentage of your peers and your chapter and your community, that's not just your chapter, who are working remote. That I think we all would expect that, but that puts a quantitative assessment on there. You have 4% of people who are going to a physical workspace right now. Very important to acknowledge that some people are going to physical workspace. There can be a lot of reasons. Maybe they have a very accommodating workspace that allows them to keep physical distancing. Maybe the people there are not feeling as uncomfortable with physical separation. Maybe they're in an area that is not as heavily, not as much advisory on restrictions right now. There could be a lot of reasons that might be the case, but 3 people or 4% of the respondents answered that they are going to a physical workspace. 13% or 11 respondents were actually remote even before this pandemic, right? So that's pretty much status quo for them. And then 3 respondents or 4% are not going to a physical office, but it's for some other reason, right? So that kind of gives you a little bit of insight into how much this disruption is affecting some of your peers, some of the people that are on this webinar with us, And as you can see, with those kinds of percentages, the disruption is pervasive. It's impacting us in a lot of different ways. And a lot of us are adapting through formats like this because necessity is the mother of invention, right? We're using collaborative workspaces. We're transitioning to cloud. We're having virtual meetings. People are using Slack a lot more. People are using Microsoft Teams for all different kinds of things. People are using Office 365's workspace. People are using Google Suite for Business, all different types of tools to enable them to remote, collaborate, communicate, and manage their projects effectively, even though they're not sharing the same physical workspace. And it's really been an interesting sort of thrust into digital transformation, right? Something that I think as IT assurance and risk management professionals, IT auditors, cybersecurity professionals, educators, trainers, these kinds of people, we've been very excited about the opportunity for digital transformation. And what this has done is, for better or for worse, in some ways, it's sort of fast forwarded a lot of the things that were sort of on the project horizon, things that I was talking about, like the collaborative workspace environment, things that are involving different types of communication tools, and honestly, also communication patterns. The way we're communicating is very different now. The entire experience is being thrust into digital transformation. This brings with it, of course, opportunity and also risk, right? Because now that we're relying even more on these types of tools, even more on these types of virtual environments, even more on these new experiences, there's additional reliance and additional exposure there if those things are subject to failure or non-reliability or difficulty in maintenance or inability to scale. I mean, we all saw that, speaking of challenges in scaling, right? We all saw that Zoom was not necessarily prepared to scale as quickly as the marketplace adopted it, right? They didn't necessarily have a lot of configurations for security turned on by default. And as a result of that, there was all kinds of Zoom bombings. They weren't necessarily scanning their credentials of their users against previously exposed data breach lists. And as a result of that, there was some credential stuffing where some hackers took an old list that was 4 years old and just started trying the credentials against Zoom. And guess what? Since people don't often use password hygiene, they don't maintain individual passwords for every single type of account, and they don't necessarily change and update those passwords. There was a lot of success in that attack, and Zoom had to come forward and announce that that breach, and there was all kinds of issues there. So we as organizations are also facing the challenges of quick transformation to new environments, quick transformation to new tools and platforms. And what does that look like? What are the risks? What are the uncertainties involved in that? How does it produce new exposure to us, especially us as IT auditors, looking at the risk profile of the organization and the ability to manage risk against management's risk appetite? It creates a lot of uncertainty that we're now trying to address using all different types of tools, technologies, platforms, but also new types of approaches and better use of pre-existing approaches, some of which is data analytics, right? We're taking data and information from these platforms, which is now oftentimes digitally native, and turning that data into knowledge, and then trying to translate that knowledge into value, right? The highest level of data analytics at the very most abstract way is how can we take data, turn it into knowledge, and then ultimately turn it into value. For us, a lot of times the conversation is about managing risk, especially in IT assurance, right? We're trying to manage risk around these different types of tools, platforms, and for the organization, but also positive value, right? There's the other side of that coin, which is opportunity. ISACA's mission is to inspire confidence that delivers value through technology, right? So we're trying to build trust and value in technology. So it's not only the risk, but also opportunity. And so that's what we want to talk about today, how data analytics can better help enforce and create that kind of opportunity for you, for your organization, and how can we be good stewards of that type of information and of those types of professional skills. So our learning objectives for today are basic concepts in analytics, understanding how to develop an analytics program and an analytics portfolio and specific analytics around targeted objectives that are specifically relevant to IT assurance as well, and understanding how that impacts the audit, the auditor, the internal auditor, the external auditor, anyone else also providing assurance, quality assurance, risk management, governance professionals as well, compliance professionals as well. And so something else that will be a bit helpful for me is understanding a bit of your current knowledge level as you perceive it around this topic of data analytics. So once again, I'm opening a poll right now, and I'm asking the question, how would you describe your current knowledge level for topics and issues relating to data analytics? And so you have the option of saying that you have very high knowledge, you're very comfortable, very competent, somewhat high, you feel fairly competent in this area, neither high nor low, you're kind of in the middle, somewhat low, or even very low. Maybe you're just being exposed to some of these topics. Maybe a lot of this information is new to you. Maybe this is something that you kind of need more foundation with as well. This, again, will provide you insight into your peers. It'll also help me have a bit of context for framing this conversation, how much emphasis to focus on some of the more preliminary and basic fundamental concepts, how much to expand the conversation towards more advanced concepts, so that you get the most value out of our hour or so today, this afternoon. So it's been about a minute and 15 seconds out of the 101 participants on this webinar. We now have 82 people who have responded to this poll, so I'm going to go ahead and close it, and then I'll also share the results with you so that you can see it. So we had an 80% response rate, nice benchmark against the previous 80% response rate, and you can see that the majority, well, the largest number, the largest group is neither high nor low, sort of kind of in that in-between area, maybe some good knowledge of fundamental concepts, but not a lot of knowledge over more of the advanced application types of concepts. So that's where 40% of people are. And then you have 30% of people who are somewhat high, pretty good comfort levels. So that's about a third of you. That's nice. 3 people actually said that they have very high knowledge of analytics. Excellent. Glad to hear it. 21% people said somewhat low, so maybe some emphasis on some concepts there. And then 5% of the respondents said very low. So don't worry, we're going to be covering basic concepts as the learning objective says here, but then we'll also talk about some more advanced applications. And as we can see, it's a broad spectrum of people feeling comfortable about their knowledge level right now, but we're going to cover such a broad amount of information that I think we'll be able to raise at least that base up a little bit, and certainly provide you some good context for doing additional research and doing your own discovery around this type of topic. In the meanwhile, someone is asking if this recording will be made available to members of your chapter. I will double check with your chapter leadership, because I would very much like to make this recording available to you, and I suspect that they probably would like that as well. So I will make sure to follow up on that. So providing you a little bit more background about my perspective on this specific topic, right? So that you can understand where some of my perspectives come from, where some of my conversation points are coming from. I work for a CPA firm. It's in South Florida. It's been here for more than 55 years. I work in the risk advisory services practice of that CPA firm. I am the director of cybersecurity and automation services. So a lot of what we're talking about has to do with assurance around information systems, as well as developing and implementing automation in these types of information systems, especially with an emphasis on quality, especially with an emphasis on analytic insight. What we've discovered is that a lot of automation projects, a lot of robotic process automation projects, and just automation projects in general, are very closely twinned with analytics projects because of the data that becomes available as a result, and because of the additional insight that's necessary for tracking. I'm also an adjunct professor at Florida Atlantic University. Go Owls! This fall, I'll be teaching a data analytics for accountants class. You're going to get actually a lot of insight into what that course is going to look like in our afternoon conversation today. But in this conversation, I'll be focused a lot on IT assurance. And then, like I mentioned, I'm the president of ISACA South Florida, so it's a pleasure to spend this time with you this afternoon. So let's start off with a brief conceptual framework of how to develop analytics for an organization, how to take data, turn it into knowledge, and turn it into value at your organization where you are now, and also as a skill for you going forward. So there's a framework called the impact cycle that was developed by a couple of researchers, Eisen and Harriet, back in 2013. And this basically creates a cycle for developing this kind of knowledge and value, where impact is an acronym that stands for identifying questions. So what kind of questions do you want to ask of your data? Mastering your data, understanding what exactly you're looking at, what's in there, what are some of the nuances and issues that relate to the data, as we'll see. Performing procedures against that data. So this is where you actually start to develop analytics, whether it's discovery or whether it's some kind of analysis that you're going to further present. And then addressing those results, you start to make sure that they're valid with expectations, maybe comparing them to benchmarks, maybe doing other exercises with them, communicating those insights. Obviously, after you've started to turn this data into knowledge, you have to communicate it and share it with others to make sure that you're turning it into value for the organization. Tracking outcomes, very important that you continue monitoring the same types of data points over time so that you can see any kind of variability, so that you can track progress, so you can identify issues, just like we believe that monitoring is a cornerstone of information assurance in the first place. And then understanding that this is a cyclical process where value is delivered over time and built up, and that the maturity of an analytics program, of an individual analytic, of course, but also of an entire portfolio of analytics, is built up over time and starts to experience synergy among the work that's being done and that sort of thing. So this cycle is going to provide us a framework for our conversation. So we're actually going to step through these individual steps and talk about some of the nuances and issues that relate to IT assurance relating to all of these. So when you start with the first step, identifying questions, it's very important that just in the same way that we do a top-down approach for risk assessment, a top-down approach for auditing, your questions also have a top-down approach. And it doesn't get more top-down than the vision, mission, and values of the organization, right? The actual highest level sort of purpose of the organization, and then the very next level, how the vision, mission, and values are communicated into action, the objectives, the strategic objectives that are being set at your organization, and then the key results, the way that those objectives are being tracked. So you hear me using the words objectives and key results. I'm using those specific terms because of a framework called OKR, which we'll talk about in just a second, as a way of setting objectives and then tracking results against objectives. And I'll give you some information about where you can look up more information on that. And then, of course, once you've set those objectives and then you're tracking those results using analytics, then you have an even further level down where you're communicating those through conversations, you're providing feedback, you're socializing the results, you're responding with recognition for achievement of benchmarks, so that you're actually working your way through the cycle iteratively at the highest level, but also on the individual level as well. And that's a great place to start the conversation about OKRs, because objectives and key results, as was explained by John Doerr in his book called Measure What Matters, where he talks about all the good work that they did at Intel for tracking their strategic objectives and then translating them into individual accountability points, is perfectly exemplified through this type of framework and through the work that they did there. And that was, they even set these type of objectives not only for the organization, not only for departments, but also for individuals. And when they did it, they used some strict rigor in the way they did it. When they said, okay, we want to accomplish this objective, we want to launch this project, we want to increase the effectiveness of this project, or we want to increase sales here, or increase quality here, or reduce errors here, then they specifically set these types of key results or measurements or benchmarks to track that progress. And that is, they highly preferred quantitative measures, right? Not just nominal measures, not just a name for something, not just high, medium, low, but actually some kind of quantitative measure that translates into a data point that is measured in numbers or some kind of percentages, even when it needs to be translated into percentages, or very often dollars, right? When we want to actually talk about measuring progress. The key results or benchmarks or analytics also need to be measured sequentially, right? So we need to establish some kind of frequency for how often we're going to revisit these, whether it's daily, we're going to look at this metric, weekly, monthly, quarterly, yearly, every 3 years. You start to see that sequence, the fact that it continues to be revisited, is not just set once and then let go and then we go check some other metric the next time. No, we need to be consistent and persistent, right? So persistence, literally storing that data, right? So they have these dashboards or measurements or metrics that they're going back and visiting on some kind of sequence, some kind of frequency, and they're storing that information so that it can be looked back. And oftentimes, in the spirit of transparency, they're making this available to the entire organization. So a lot of organizations that are really embracing an analytic approach are also doing this kinds of things. You've certainly seen this at Google. You've certainly seen this at Amazon. You've certainly seen this at Facebook, at a lot of organizations that use a data-driven approach. Evaluated, right? Once you actually track something and then you're sequentially visiting it on some kind of frequency, some kind of basis, you have to make sure that you're going back and you're explaining any kind of deviation from the results. And then these should be obvious metrics, right? They need to not necessarily be debated every single time. Oh, wait, what do we consider an incident? What do we consider a patched server? What do we consider a phishing email or a report? That needs to be defined in a way that doesn't require reinvestigation every single time, and especially reinterpretation of the metrics, so that you end up with some traditional types of questions like cost reduction of X, so staying very quantitative, by Y date. So also having that frequency and having that ability to go back and measure it on those periods and setting a deadline that you actually want it to be accomplished. Making sure that you set your metrics and set your objectives and then measure against your objectives in that way. Revenue increase of X by Y date, productivity increase where that's defined in an obvious way as to how that's measured, satisfaction, efficiency, etc. Those will be a good way to set metrics and to set goals and to set measurements in this type of a framework, in the OKR framework. And that type of information would come from all different types of sources across the organization, whether it's call centers, customer relationship manager, the ERP system, supply chain information, revenue information, the department, procurement, entire departments, inventory. These are very traditional types of data sources that you would use to pull from these metrics, that you would create those types of metrics, that you would do analysis against them to make sure you're tracking the progress that serves and ties into those higher level objectives that feed the mission, feed the vision, feed the strategic objectives of the organization. And when we specifically talk about some of our roles, where it has to do with IT assurance, cybersecurity, risk management, those types of things, then we start to tie in to those higher level objectives in our domains, which includes things like reduction of exceptions, right? Whether that's an exception in an audit scenario or an exception in some other kind of deviation from quality, whatever's relevant for the organization. Increasing uptime of X% by Y date. So maybe that's something that's found in your service level agreements or in your objectives for providing service or quality by a certain time, responding to tickets by a certain time, that sort of thing. Exposure value, right? So decreasing the amount of vulnerability that our organization faces and measuring that again quantitatively and then tracking that over time. Awareness rating, so we'll talk a little bit about cybersecurity awareness and how maybe that may be measured over time for the purpose of also reducing exposure value. So these types of things can be related. And then of course, incident response time, very germane to our type of conversation. And for us, looking at this kind of information, the data sources may include things like your support desk application, your SIM or your security information and event management software. Sometimes this is log aggregation and analysis. Sometimes it's very comprehensive threat management solutions. You know some of the names that are out there that provide those types of services. Your firewalls and gateway devices and other types of IDS, IPS that may be sitting at the gateway or sitting in between networks are capturing a lot of information. Your backup management solution may be capturing a lot of information. Your configuration management solution and or process related to that solution may be capturing a lot of data. Your encryption management solution, your endpoint security solution, your antivirus solution, all of these are capturing all types of data, and then hopefully you're finding some way of gathering that and storing that. We'll talk about that. Your asset inventory, maybe you've got, I don't know, Landsweeper or something like that in place, and uptime and processing types of metrics that are being provided by your perhaps and probably at this point your cloud services provider, whether you're using AWS or Azure or Google Cloud Compute, something like that. You're probably getting a lot of metrics from those sources as well. And when you're able to actually extract that data, or when you're trying to get to that data, it's probably going to be in some kind of traditional data store. This is where certain skill sets become very relevant to developing a comprehensive and effective analytics program, and in working with different types of environments like Excel. So if you're going to be doing some initial or exploratory analysis or some preliminary analytics, maybe using Excel, using a very light database like Access may be relevant for your environment. Starting to sort of move up the capability spectrum, maybe you're using some kind of open source database solution like SQLite that provides more capability in terms of database management than Excel, obviously, but not necessarily as much as some of the more traditional enterprise services for offering database services, things like Microsoft SQL Server, Postgres, or MySQL. These are some of the more robust enterprise level types of stores that you're probably going to encounter, and you're probably going to need to have skills, because maybe these are the stores of those previous sources, or maybe this is ultimately where you're storing the information, because a lot of times now with the types of volume, the amount of data that's going to be coming in from these numerous different sources, the variety, we talked about all these different sources of information that are providing all different types of data points, and the velocity, how fast it's going to be coming in on a daily basis, you start to encounter, especially in big and more complex environments, you know, the proverbial big data that creates all new types of challenges, right? So when we say big data, what we mean is that a lot of these hand-coded or sort of out-of-the-box solutions are not going to work, right? There's a lot more complexity that needs to be addressed in making sure that you're going to be able to get to your information and extract it from where its existing sources, and then start to transform it, so perform manipulations on it, arrange it in the way it needs to be arranged, and then ultimately load it into some kind of engine for performing data analytics, or for performing additional analysis, or for creating your dashboards, or for creating whatever solution it is that creates visibility at your organization. And that's where you start to get into the very important data engineering conversation. And this is a very specific skill set that starts to become crucial and a bit of a hurdle if it's not in place when you're trying to move up the maturity chain for developing an analytics program. As a matter of fact, Gartner said that 85% of big data projects don't make it into production. And some of the reasoning behind that, there are many reasons, but some of the reasoning behind that is that this process here, the extract, transform, and load process, is so burdensome and so difficult to recruit talent for, and so difficult to scale. That is, when you build something by hand and you build a prototype and you say, okay, this works, we actually want to have insight into the uptime of this server farm on a daily, hourly basis, and receive alerts, notifications on it on a daily basis, so that we have our team monitoring that. Well, when you start scaling that across a large number of environments, or you start scaling your solution across varied types of tools and information, that can create a huge boundary for success And so that's why it's very important to make sure that you understand that from the beginning, and when you're building your prototype and when you're actually starting to do some of the preparation of the data, understanding that this skill set will be crucial. So preparing the data may involve things like munging information, munging the data, and normalizing the data. So munging, sometimes people say data wrangling, sometimes people say cleaning and preparation, sometimes they include it in that ETL process in conversation, is where you are pulling the data out of its original store, you're exploring it, making sure you understand it, understand the entire schema or the different tables and the properties of those tables and what are the different attributes that are being stored in that information. You transform it into whatever form is necessary, whether you pull it out in a flat file that's just a very simple, almost like text file that can be uploaded into some other environment, or you end up loading it into a separate database. You enrich it, that is, maybe you change it into the type of form that you need to work with. In certain sources, it's coming out as something as simple as a negative number, and we need to look at all positive numbers. And so, enriching it and transforming it to the way that it needs to be required for our analysis. And then also validating it, right? Making sure you have completeness in the data, making sure you have integrity in the data. And then I've also got normalizing up here on the screen, because I cannot have this conversation about preparing the data without at least touching normalizing. I'm probably not doing it the necessary amount of justice, because there are entire careers built on this type of topic. But when you normalize data, you're making sure that it's complete, it's not redundant, so it's put in a good structure of a traditional database management. It's complying to and following certain business rules. So just like I was saying, certain numbers need to be negative or positive, or they can't fall below certain boundaries, or maybe it has to be defined as text, or it has to be an integer or a float, or whatever the case may be. And then also integrated, so building that pipeline to make sure that it's following in with the other processes. And then if you have database administrators on your teams, then they'll talk about the normal forms, the first, second, third, and even beyond normal forms of making sure that the data is structured according to the highest level of standard. And the reason this is so critical to include in this conversation, among many, is that 50 to 90% of business intelligence professionals' time is actually spent cleaning the data. That was true in 2015. You saw Gartner's statistic a couple of years later. It continues to be true today. If you look at the job postings for data science and data engineering, you're going to see oftentimes 10 data engineering positions for every data science position, because the information must be prepared before you can do additional analysis on it. And this is where one of the topics that's most close to home for me becomes very relevant, and that is automating a lot of this pipeline, automating a lot of this preparation process, and how that can help empower and enable your analytics program using things like robotic process automation, whether it's a enterprise RPA platform, or whether you're using scripts to run different types of jobs that are very rule-based, very routine, that normally a person would have to do, but instead you can build in some kind of automation, you can build in scheduling, you can build in quality around those things. This would be critical to scaling an analytics program. So that's why I say that RPA projects and analytics projects oftentimes are two sides of the same coin, because this is so critical to creating value from your data. And then in the same sort of 10-to-1 relationship, right, if you're automating the pipeline, then about 1/10 of the value from there can be gained into automating some of the analysis, right? We traditionally call that some machine learning, right? When you start to build in additional ability to capture errors and improve quality over time. And then in the certain very specialized cases, you start to get into some deep learning scenarios where you're able to create value directly from the information from the data that's being fed into a pipeline. These start to get very specialized. And again, these are sort of 1 to 10 relationships. That is, for every one deep learning project, you may have 10 machine learning projects. For every 10 machine learning projects, you may have 100 RPA projects. So it's something to kind of keep in perspective as far as the criticality and dependency of these sorts of competencies on your way up to building an analytics program, which can consist of different types of analytics that are also dependent on one another. And so these analytics can be put into different types of buckets so that you have analytics that are descriptive and they're sort of summary statistics, and even the types of things that I was showing you on the poll, and to where they're diagnostic, to where they're revealing something about the condition of some sort of state or some sort of customer or account or asset in our inventory, and then predictive, where you're taking it one step further and saying, okay, now that we know something about the state of it, we actually have certain beliefs about what's going to happen to it in the future. And then prescriptive, where you actually say, since we have some kind of educated guess or hypothesis about what's going to happen to it in the future, we actually want to take certain measures in response to that. And again, these types of things create a dependency on the way up, to where traditionally, in order to arrive at prescriptive, you need to at least have predictive competency. To arrive at predictive, you need to at least have diagnostic, etc., so that we can start to look at some of these types of analytics and see what we mean by them specifically. So the descriptive analytics, you're very familiar with these types of things. You actually probably have a good deal of basic knowledge about these types of things, at least working knowledge with your comfort set with the work that you do, and enough to perform the activities that are required of you at this time. Descriptive analytics, things like summary statistics, whether it's things that you're doing in Excel, creating sums of columns or checksums, or creating averages and comparing averages across different groups, finding the median and its deviation from average so that you can kind of understand the skew of the data set, identifying the minimum and maximum boundaries of the data set, understanding the certain counts and frequencies of how often a data point appears, understanding standard deviation, or how far away something is from the mean or average, and maybe even applying a z-score to that, so how many times of standard deviation something is away from the average. Quartile, basically dividing it into fourths, your data set into fourths by some kind of metric, and correlating, comparing different data sets and seeing how good they are at predicting one another, how much they move together in certain directions, and even doing reduction and filtering. You do this all the time with your data sets in Excel, to where you remove certain types of things, filter out certain types of things, highlight certain types of things. This area is one of the reasons that I believe you actually have a very good foundation for analytics to build upon, because you have these skills and they allow you to sort of move into the next step, which is diagnostic, right? So in diagnostic, you're saying, okay, now that I understand some summary statistics about something, now that I understand some of the high level sorts of information about this, what sorts of conclusions can I draw at another level of abstraction up? How can I start to perform some profiling? How can I start to do some cluster analysis, similarity matching, co-occurrence grouping, those kinds of things? So profiling, let's say that you're looking at certain types of assets, or certain types of zones or blocks of IP addresses, or certain areas geographically, and saying, okay, they're logging into our resources typically on average around this amount of time. Here's usually the minimum, the earliest that they log in, here's the maximum, the latest that they log in. You start to look at deviations from those types of information, and you say to yourself, okay, now I can create a sort of profile about what looks like my typical user, my typical internal user, my typical customer, something like that. And then when you start to identify deviations from that typical, then you can say to yourself, okay, this is something that something that justifies further investigation, right? So profiling, using that to identify your typical versus looking at something different. Clustering, I have a picture of clustering on the screen. This is clustering using what's called a k-means algorithm. This is not a conversation about algorithm, but a lot of these tools have these types of competencies and capabilities built into them. Clustering is where you start to identify some number of different groups so that you can say, okay, these sorts of patterns share these common attributes, these sorts of data points, these sorts of, again, information assets or users share these sorts of data points, and they have these things in common. So I can start to create a group, maybe even start to develop profiles as a result of some cluster analysis. And I can maybe even start to do some risk analysis around that. The firm that I work for has a very large banking practice, and so anti-money laundering analysis becomes very important in some of our engagement and some of our model validations. And so looking at certain clusters of activity, certain types of profiles of behavior, deviations from those profiles, that can become very important in an AML scenario. And then related, looking for similarity or co-occurrence in the same types of data sets can be something that also provides insight there. Moving up the chain of value to predictive types of analytics. So we've already covered diagnostic and we've covered descriptive. Now we're moving up further into predictive, where you're saying, okay, now that I know something about this data set, now I know something about this asset, this user, this threat source, this whatever it is, what sorts of predictions can I make about it? This is where you start to get into some of the heavier types of statistics topics. If you don't have comfort with some of these topics and you are more interested in this area, this will be a good place to start developing additional skills and competency around regression analysis, around classification, around link prediction. So regression, you can see here in this chart a linear regression where you have a scatter plot and there's different things that are measured against an independent variable and a dependent variable, and you're saying to yourself, or an X and a Y, right? And you're saying to yourself, okay, if I have the data that's over here, if I have people in this zone, or people with this profile, or people in this department logging in this time, and that sort of thing, what sorts of predictions can I make about it? If I know that a data breach consisted of a certain number of records, can I start to estimate the amount of monetary damages that will involve, right? So if my monetary damages depends upon, in my hypothesis, the number of records that were breached, then that would be monetary damages would be a dependent variable, and its relationship to the independent variable. And then I start to create a line that will help me do prediction against, even if I just hypothetically say, okay, what if this number of records get breached? What if this department has their records get breached? Now I can start to make predictions about the monetary damages, and that's something that regression is very good for. It doesn't have to be only linear, right? We can have other types of shapes which start to create very different sorts of scenarios as well. Classification, starting to put people into groups of maybe different levels of risks. Link prediction, saying that, oh, because this person is related to this entity, then chances are that this person who is their associate may also be related to that entity, or that this person who is related to that entity may also be their associate. So starting to predict links and that sort of thing, that will be another level up of analytics, so that you can start to get to some of the more exciting, innovative sorts of things, which are the prescriptive analytics, the things when you say, okay, now that we know something about this information, we know something about this scenario, this loss event, this asset, what sorts of things can we predict about it? And because of our predictions, what sorts of, for example, risk mitigation measures do we want to take around that now? Do we want to go ahead and start isolating this, which looks like a threat? Do we want to start to block certain IP addresses automatically from our gateway filtering, that sort of thing? And that's when you get into decision systems and the proverbial artificial intelligence. This is not a conversation necessarily about AI, right? Because that would be an entirely different track, but it's important to understand that when you get into this level of analytics and analysis, you start to talk about things like deterministic approaches versus probabilistic approaches, and certain models can be built using probabilistic approaches, where you say to yourself, I'm going to define parameters, but I'm not just going to create a point value. It's either yes or no that this is the parameter, just because someone signs on at this point in time, or just because this email comes from, includes this type of words, it's necessarily malicious. I'm going to start to assign it a probability. And then I can start to do some probabilistic calculation and build a probabilistic model where you see those actual, that sort of distributions on the probabilistic approach in the screen, and you can have a normal distribution or a log normal or a skewed or some other kind of distribution, so that you're not just saying yes or no about something, you're saying there's a probability that we're kind of getting into this. And I'm monitoring that there are questions coming in, and I'll get to those at the end of the conversation so that we can keep moving through this quickly. And when we start talking about probabilistic modeling, that's when we start to get into the point of it's very important to understand things like, for example, Monte Carlo simulations, which is how you can create a model that incorporates critical elements like probabilistic approaches, randomness, the fact that sometimes things, the dice fall one way, sometimes they fall a different way, and you need to incorporate that into your model, and making estimates based on ranges rather than points. You don't say to yourself, this is a 10% probability that this is a malicious actor. Instead, you may say to yourself, this is somewhere between a 5 and 15% probability that this is a malicious actor based on our model. Or if there's even more uncertainty, maybe this is somewhere between a 1 and 25% probability that this is a malicious actor based on our model. And then the predictive engine can start to prescribe the proper steps to take based on those type of confidence ranges. That's why Monte Carlo simulations can be so helpful, because in a sentence, a Monte Carlo simulation is where you roll the dice some number of times, right? So you roll the dice 10,000 times. Maybe there's a bunch of things in your organization that you're trying to measure, whether or not the servers are patched, whether or not the users have been trained, and each one of these has their own independent probability, right? We have 95% patch rate, we have 97% compliance with user training, we have this sort of probabilities with phishing, and then because those probabilities are independent of one another, you can create all these different scenarios where you calculate all these independent probabilities, and maybe you make 10,000 different scenarios, 10,000 different simulations, playing it out probabilistically over time. You start to create a loss exceedance curve that can be a very valuable thing for communicating uncertainty around risk, but also information around fat tails and long tails, the very unlikely events where you start to get into huge scenarios of disruption, kind of like the disruption that we're experiencing now on a couple of different areas, and the fact that a couple of different types of disruption are affecting us simultaneously. What are the chances of those types of things happening? You can start to calculate those types of things using things like Monte Carlo simulations, as well as other tools that are statistical in nature. And when you do this, you're using the different types of analytics, not only the types, but also the paradigm approaches, right? You're either declaring something, like I'm specifically saying this is what's going on with our situation, or whether you're exploring something. Maybe at the beginning, you're kind of just looking for additional insight when you're performing those procedures, when you're assessing your results. Maybe you're just saying, I don't know if there's a relationship here. I just want to explore that now. And so those are kind of opposed on a spectrum. And then they're also a little bit related to quantitative and qualitative types of metrics. Things, again, that I said can be measured in terms of hard numbers, or things that are more like classifications, things that are more like names or types of things. And so the easiest way to sort of walk you through some of the understanding of these different types of analytics and the visualizations that most closely relate to those things is to sort of kind of go through some of these traditional types of visualizations that you are familiar with, but start to link that to the type of exploring, to the type of communication, to the type of value that you're looking to create. So you're familiar with bar charts, pie charts, heat maps, these sorts of things, but you may not have necessarily explored when it's good to use these certain types of visualizations. And so there are actual, good approaches as to when it's used, when it's better to use these types of charts versus something in the instance that it's more qualitative. When you, as opposed to when you have something that's more quantitative, maybe it's better to use a box and whisker plot, a field map, a proportional symbol map, a scatter plot, a line chart. And the easiest way, since they're visualizations, the easiest way to communicate with you about this is to show you some of these things, right? So comparisons, here we have qualitative information, right? Because desktop is not a number. Mobile device is not a number. Tablet is not a number, right? But I want to be able to do an analysis. So these are nominal categories, and I want to be able to do a comparison. And maybe it's better to do a comparison of this using a bar chart, so I can quickly identify where the cutoff range is, quickly identify the difference between the different categories, or maybe it's better to use a pie chart when I'm trying to understand conceptually at a higher level what proportion this makes to the entire whole. So you can see that on the pie chart side, much easier to visualize as it relates to the whole, whereas on the bar chart side, you can see that much easier to compare the actual sizes and the proportional difference between these different categories. So that's a good example of when to use pie charts versus bar charts. And then symbol map versus proportional symbol map. So symbol map, maybe we're trying to identify, oh, there was an actor here. This was a threat. This was this type of activity. This was not. Here's how many threats are coming from over here. Or in our case, here's how many cases of certain types of sickness or illness are being measured or testing or those sorts of things, and just putting that as a symbol on the chart versus putting it as a proportional symbol, which maybe communicates a little bit more in terms of relativity, right? The relation from one place to another. You see that the bubble on the right-hand side is swelling when there's more of something versus the bubble on the left-hand side it's not changing in size. So it's easier to make immediate conclusions about geography on the right-hand map, but it's easier to read and distinguish on the left-hand map. So knowing who your audience is and what your ultimate message is for when to communicate symbol map versus proportional. How about word clouds when we're doing surveys? Maybe you're doing a survey about the types of things that data owners in your organization are most concerned about. Maybe the types of threats, maybe the types of vulnerabilities, maybe the types of things that keep them up at night. Maybe ISACA is actually doing a survey of CISOs, something like that. And so then one way to communicate visually some of those results and proportionally, again, is to create something like a word cloud. You've seen these before. Maybe you didn't know that that's exactly what it was doing. It was swelling in proportion to the responses so that immediately there's a visual stimulation as relates to the level of proportionality for that topic. Okay, so we were talking more about the qualitative side of things, and now we're going to talk more about the quantitative side of things. And this is when you have measures that are absolute and hard numbers that have been derived from the system. Now you can start to mix in some of your summary statistics a little more effectively with your visualizations. One of the ways to do that may be through a box and whisker plot, right? So a box and whisker plot is a real good way of showing outliers, of showing means or averages, of showing medians, and then of showing quartile ranges. Remember we talked about dividing those in terms of 4 categories based on the count and the frequency within the overall population. So this helps you create this box and whisker plot, and I've labeled the actual data points so that you can see that on the left-hand side, the medians right in the middle, the first and third quartile are identified there as boundaries, so that you can see that actual median 50%, and then you also see the outliers. What especially is being drawn to your attention, especially when we're talking about IT security, cybersecurity, developing value and controls and responses to different types of information assets or data assets, then maybe you end up with something on the right, which is actually from a solution that does a box plot analysis looking for outliers statistically, on a statistical basis, across a number of different variables in their data set. Scatter plots. So a scatter plot where you have an actual a couple of variables that you're comparing. And this one we're looking at cybersecurity awareness and versus readiness, and maybe how much of a risk that means someone is inside of the population, right? So where can we identify our most at-risk and most vulnerable employees and team members and make sure that we focus a lot more of our effort in them? Well, we put these 2 relations on a variable and then actually create groups in this and put it on a scatter plot. And now we can sort of start to divide these into clusters and say, okay, we're going to spend the majority of our time retraining and further addressing and mitigating around those users who are most at risk. We'll spend a little bit of time with some of those who we've decided are immediate risk, and much less time, perhaps, maybe just the minimum compliance requirements with those who we've assessed as being at low risk based on some kind of analysis. This was presumably generated from some kind of testing and survey of the users, probably over time, so that they can track someone's readiness and how dependent their awareness is upon their readiness as they decided to measure it in that assessment. And then finally, line charts, something you're very familiar with, of course, from things like financial analysis, right? In this instance, we're talking about data breaches versus millions of records exposed, and starting to look at the relationship on an aggregate level of how those two things vary together. A line chart is especially good at showing changes over time, because on the bottom axis you have years as to when the data breaches occurred, and then on the top you have number of records exposed, and you can sort of start to see the types of relationship of number of records versus the actual data breach instances themselves, and the relationship that those create between the two over time. So a line chart, especially good for showing trends. You can even drop a trend analysis on top of each of the individual lines and start to see that they're headed up and at what gradient, and how much attention of yours that deserves. And as far as for performing these types of visualizations, there are a number of tools that are out there. Some of those tools are built right into the environments and stores that we talked about earlier, such as Excel, right? There's good charting in Excel, but for business intelligence and for some of the more advanced analytics that's being performed now, by far it appears the most common tools out there are the Microsoft BI sort of suite of tools, which includes Power BI as well as Excel, as well as Power Query, and versus Tableau. Microsoft BI having a tremendous amount of popularity and adoption in relation to people using their Office suite a lot more. So these are two examples. There are many, but there are a number of advantages that there are in using a comprehensive tool set like something like this for your organization, so that over time you can develop these analytics, measure against your progress on objectives, continue to measure that frequently, keep a persistent record of it, learn, take lessons away, and then build up your analytics maturity over time. Because ideally, you would love to, even if you don't have a very robust analytics program right now, you would love to be able to start with sparse analytics, with the data that you can gather, using the pipeline that's manageable for you at this time, and then start to build that up to more functional metrics, maybe on dashboards that you're actually analyzing every week, every month, every quarter, and then using those to make decisions, using those to assign and allocate resources, using those to consider even pivoting an approach that you're taking to a certain type of threat, or on a project, or on a new implementation, so that as you start to develop up those competencies even more, maybe you can even build, the more traditional data warehouse, data marts, data lakes, and start to develop some additional competencies around that, and move your way into ultimately some of the most exciting types of advances, where you find hidden insights using things that are often labeled as artificial intelligence. As you're managing these types of projects, of course, you're always constraining yourself. We're always trying to deliver value, right? So we're always looking at the business case, how much effort, how much time, what are the scope, what's the things that we need to accomplish for this project, making sure that we're controlling cost, and we're ultimately delivering value, a very, very high priority for us who are in assurance. And some of the ways of making sure that you're able to properly organize around certain sizes of projects is understanding the types of roles that are oftentimes found in these kinds of teams, whether it's including the data owner, you have analysts who are doing some of the more exploratory type of analysis, understanding the business scenario. You have engineers who are actually building pipelines, data scientists who are actually running experiments against hypotheses. If obviously that's at a higher level of competency, if you start to get to that level, some kind of data science manager or project manager, maybe those are separate, maybe those are together. Ultimately, some kind of data architect overseeing the entire portfolio of projects, and then Very important people to be involved, understanding the type of data you're working with and relating that to your data classification policy, making sure you're keeping it secured throughout the entire thing. So you want information security involved the entire time, having the proper infrastructure team on your side and making sure that you're communicating them, maybe even having a sponsor who's actually driving, hopefully budget as well as cultural will behind the type of project and communicating the vision, communicating the value, helping you gain that top level of buy-in from the stakeholders. And maybe when you're just getting started, maybe you're building some of these resources internally. Maybe you're having people just practice on little projects, train themselves, that sorts of things. Maybe you're trying to grow a little faster, so you're buying resources. You're actually hiring somebody who's been involved in a data analytics team before, and a data science team before. You're starting to recruit and bring those people in, or the proverbial leasing, where you bring in consultants, like a lot of us who are in ISACA, who are offering our services to our clients, going out, implementing a project, helping analyze the business case, helping assess value, helping management then either decide to continue the project, take on another project, pivot against the project and go a different way. So the sort of proverbial build by lease scenario. And as you're trying to move further into this path and drive yourself also and your skills up in competency over time so that you can contribute to a more robust analytics program, wanting to make sure that you have these types of areas of knowledge that we've talked about today, developing the skills. I've honed specifically on the data engineering because that's so important. So understanding even just the basics of databases, and then if you have a good understanding of databases already, starting to work on those skills, starting to build up your SQL fluency, starting to understand and being able to implement normalization even better would be a good skill to pursue. And then finally, the domain experience can never be underestimated, because whether you're in healthcare or you're in banking or you're delivering a SaaS product, understanding exactly which of the important metrics which drive to the top level strategy, the vision, the mission, the values of the organization, and making sure that you're speaking in the way that management understands, that stakeholders understand, that external stakeholders understand, and that ultimately drives towards the value that you're trying to deliver. So if you'd like to discuss this further, I'm happy to discuss it further. Here's the types of services I usually offer so that you know. We do RPA consulting, where we build and implement and deliver robotic process automation solutions. I do SOC reports. Our firm does pen testing. I'm involved more on the risk analysis side. We actually have white hat hackers. Privacy consulting, we do a lot of HIPAA work, and we have attorneys who are on our team as well. IT risk assessments, I think every single one of us is involved in doing those. And model validations, I spoke a lot about AML, specifically anti-money laundering, in the financial institution sphere specifically. We have an entire team dedicated to doing that, which I support on the data integrity and processing side. And I'd love to stay connected with you. So please feel free to connect with me on LinkedIn, connect with me on Twitter, connect in other ways, reach out to me, send me an email. My email can be gotten from those. These are QR codes. You can hold up your phone right now and obtain my contact information so that we can stay in touch. But something that I'd like to do right now is make sure that I also address some of the questions that you had throughout the presentation. I know that's a little bit fast. It's a big topic. It's very comprehensive, but there's a lot to dig in here. And I hope what I gave you is some of the tangents that you can dig into that are very exciting and where you can actually provide some immediate value. So someone says, do you consider the terms analysis and analytics synonymous? If not, how do you describe their differences? I love these philosophical questions. This is actually, believe it or not, what I spend a lot of time thinking about. I don't consider them synonymous. I do consider them related. In my own, okay, this is Rob Valdez speaking. This is not published research or any textbook or citations. I a lot of times think of analysis in combination with metrics, creating analytics, right? Doing some analysis on some metrics, just like we talked about, those way of creating benchmarks and key results, things that are quantitative, persistent, measured over time on some determined frequency, that are obvious in their definition. Analysis done in that methodic way, using these types of tools, that's how I consider, and that's how I define analytics. So that I hope answers your question, but I'm happy to address it further, just in case you have additional thoughts on that. And then let's see, other than quantitative risk assessment, have you ever used a Monte Carlo simulation is a question. Okay. The way that I personally have used a Monte Carlo simulation is to create, I was kind of talking about it generally, but I'll speak about it a little bit more specifically, is to create a loss exceedance curve in assessing the potential amount of monetary risk that an organization faces on an annual basis. So that was very specific, that case that I mentioned to you. So we were able to take a number of different loss event scenarios, and I think we had in one case we had as few as 10, and then in another case we had as many as a couple hundred. That and so you can build this to scale according to the organization that you're working on, right? You could take all different kinds of loss event scenarios, assign each of these scenarios a probability, assign each of these scenarios not a point of lost damages, not a point of monetary damages, but a range. In other words, if we experience this type of outage, we expect it to cost a range of as low as this monetary dollar damages and as high as this monetary dollar damages. And then taking all those different scenarios and then running many different permutations of those scenarios, as many as 10,000 or as many as 1,000,000 times. Then you put that on a curve and you can actually see, okay, we have a 15% probability of this amount of loss in the next year, according to our loss exceedance curve. We have a 20% probability of this amount of loss, and it's not a point, it's a scale. And I guess I can share some of that kind of information with you if that's helpful. But that's how I've seen Monte Carlo simulation done in my practice. When would a deterministic model be appropriate in security analytics? Wow, fantastic question. Lots and lots of types of scenarios where a deterministic model is appropriate. But let's say, for example, that you actually already, from your great experience, decided that when you see certain types of activities coming from certain IP addresses, blocks, in certain countries, you don't need a lot of probabilistic modeling at that point. You already know that your organization has decided that you're going to block those IP blocks. You're going to shut down that email address. That decision has already been made. Now you're getting to the more deterministic type of scenario. That's very helpful. As opposed to the probabilistic when you need to, when you have a lot more uncertainty, right? So determinism versus probability-based really is a function of uncertainty. If you and your team believe that you've reduced the uncertainty around this question, perhaps deterministic is already appropriate. Now, let's say that you're not to a level of building a probabilistic model in your competency toolkit yet. Then maybe a deterministic model is your sparse analytic approach. Maybe that's where you are in the maturity life cycle of your analytics. And it's not a function of that you actually believe it's ultimately the best way of addressing it. It's a function of what you believe you can implement right now. That might be another scenario where deterministic models would be very appropriate, because just like in Kanban, just like in Agile, start with what you can do now, today. Don't wait, don't create some gate, don't create some huge psychological boundary that means you're not going to get started until you have the perfect ivory tower. Get started today with the skill set, the competencies, the team, the processes, the pipeline, the data sources that you have right now. Are you talking about fair? This is another question. Are you talking about fair when answering the Monte Carlo simulation question? I asked other than risk assessment. Okay, so I was referring to a scenario in which a fair framework can be relevant. I'm not talking about fair, because fair, just for those who are not familiar, is factor analysis of information risk. That's an acronym. And FAIR is a framework that incorporates a lot of different definitions in risk assessment And then FAIR also creates a way of creating threat profiles. Just like we were talking about profiling, FAIR has a robust way of defining the profiles of different threat actors, which is extremely helpful for doing risk assessment. So in my practice, I have used Monte Carlo analysis for risk assessment. I have not used Monte Carlo analysis for anything else. Now, Monte Carlo analysis is absolutely used for many other things. Many things in which there are multiple variables and which the different scenarios cannot possibly be all calculated by hand initially. So you just need to understand the huge spectrum of different types of scenarios that can result. As a matter of fact, the Monte Carlo simulation comes out of the development of nuclear weapons, and that's something that they were not trying to model risk at that time. They were trying to model the effectiveness of the chain reaction given a number of different types of variables. If your scenario maybe is driving revenue or driving value or driving efficacy of shopping online, clicks, a likelihood to interact with an ad campaign, a probability of an asset defaulting, probability of a server going down, probability of all different types of things, you can model those using a Monte Carlo simulation. And the way that the Monte Carlo simulation helps is by giving you insight into the randomness, letting you use range estimates as opposed to point estimates, and creating an intelligent spectrum around which to communicate and make decisions. So whether that's having to do with opportunity, or whether it's having to do with risk, or whether it's having to do with some other types of scenarios that are important to your organization, then that will be a case in which Monte Carlo simulations may be relevant for you. So I hope that that's a good way of answering that question. I believe that someone else, let's see, chat. It looks like we may have answered a lot of the Q&A. I know that we're supposed to wrap up at approximately 2:15. So then what I will do is I will say that you know, I am a member of ISACA, and I am an enthusiast for these type of topics, as I believe you can tell. So I would love to connect with you. So please do feel free to connect with me, as I would like to hear your questions, have further discussions with you, invite you to attend our ISACA South Florida events, and better create our worldwide community of ISACA professionals. So with that, I'll go ahead and wrap it up. I'll thank you all for your time this afternoon. I'll wish you well in these times that are uncertain, and I'm thankful for people like you who are risk professionals who can communicate around topics of uncertainty, especially with friends and family and organizations right now, in a way that is meaningful and thoughtful and communicative, and I'm really glad to be a part of this community. So if there's anything I can do to help, please don't hesitate to reach out. Thanks very much. Have a great afternoon.